Welcome back. I've got an interesting one today and a little bit controversial in a lot of ways. Let me take these glasses off so you can see my face better. I use glasses when I'm reading, but you know, it is what it is. Look, we've been talking a lot on the podcast about network disaggregation and about commoditization and about merchant silicon, and it's kind of confusing. And I know just from listening back to the shows and listening to what I'm talking about, it's very difficult to understand what disaggregation might mean. So what I've done is put together a bit of a presentation which looks at the different pieces, and I've called it provocatively, because you need a provocative title if you're going to make this work, Networking Mainframes. Why are network devices sold by a single supplier, and why are we forced to buy them from a single supplier? Let's get going, right? So the thing about networking assets that you've got today is that you literally can only buy them from a single place. Just like an IBM mainframe in the 70s, 80s, and 90s, and even today, the whole thing comes from a single supplier. IBM designs the hardware, the software, the applications are pretty restricted by IBM. The only place you can get tech support, IBM. The only place you can get advice or sales, again, IBM. After-sales service is very restricted. There are some minor options outside of the specified ecosystem, but again, pretty much you're locked into one vendor, and they can charge you whatever you like. They can change the levels of service and support. They choose the future. They choose what it is. I call this the vendor monolith. This model of vendor monolith was very much the way that IT has grown up over the last 30 years. But then what we've seen, of course, is that this has changed. So let's cover off what the monolith is all about, right? So the good part about the monolith is that it comes from a single vendor. And that actually probably is the only positive feature. So the vendor must take full responsibility for the product. Now, just a trick here. You're not taking responsibility for the entire solution. You're taking responsibility for the product, right? Because a piece, a router or a computer or a piece of software is not a solution. The solution is what you take it. And you are always responsible for taking the product and making it work for your company, no matter what people say to be different. It's absolutely true. You are always responsible for the solution. Vendors might guarantee you a contract or a scope of works, and they'll make sure the scope of works only ever covers what the product can do, right? So even though one of the mistakes I've seen so many companies mistake is they go to the vendor to get a commitment that the product will work and that the solution will work, but nobody guarantees that. The only person who ever takes responsibility for the router working or for the mainframe or the database databasing or that the data in the database is valid is you, the customer. And so that support can be very important to making that solution work, because when you run out of expertise or you run out of knowledge or you run into a bug, and there are so many bugs in these products, in these vertically integrated products, and you know, you're stuck with one supplier. You can only go to one place. So having only one place to go for support is cognitively, like as a bias, you think that's the right solution, but actually it's not, because if that supplier is not working to the right level or performing at the top of their game, or they've decided to cut funding for support so that they can support their bottom line, or they're going out of business, or you know, whatever it is, you're screwed because you're stuck with one person. So support, there's a good and a bad. And the other things are that the product is fully integrated, that at least in theory, the whole product has been tested to work. Well, now we know that's not so much true in real life, that integration is potentially better, but you're relying on the vendor to continue to do the right sort of testing and to validate the testing and stuff over time. They also restrict the features that are on the box. So in order to meet their own profit goals or to their internal organization or disorganization, many of these companies are badly organized. They're big, huge companies that are not always well put together. Some are, many are. Some divisions are, some divisions aren't. You can't characterize a big company as dysfunctional across the board, but it's certainly possible to get a lemon from these companies, because what they do is just scope down the product. They restrict the features, they limit the capabilities, and that's a feature, right? Because sometimes those restrictions can be a positive thing. We don't let this go off into the wrong area. We don't fiddle with this, you know, whatever. On the other hand, they might not be putting features in that, you know, you might want, because they're making the decision for you. They control everything about it. They control the hardware, the software, the features, the apps. Now, we'll see later on why that might not be such a good thing, but it might also be. And finally, the system is often closed. So whatever the vendor wants, you know, the vendor who owns you as a customer, controls you, manages your account. The word manages also means control. Make sure that you don't go outside of the ecosystem. So closed also means control. You lose control by giving away some responsibilities to the vendor. Now, on the other hand, you're also sharing those responsibilities, good and bad. There's no negatives here. And the other thing about vertically integrated products is they're often limited. Like literally, there's more things that you could do, but the vendors choose not to support them for reasons that work for them. but you're the customer. They're making a product for you, right? Who's the leader here? Anyway, so that's what I see about the network mainframe. And is that the right way to go forward? I think it probably is. For some people, buying the network mainframe is the right choice. In the same way with cars, some people want to buy a fleet car from the manufacturer, and the manufacturer will give you a support for that fleet. And that's a good deal for a certain type of big company with enough buying power to get the purchase price down. But there are other people who want to do things with their cars, maybe a consumer market where the volume isn't big enough, or whatever it is. But what we're also seeing in IT is the emergence of this thing about disaggregation. So here's what I'm going to do. I'm going to talk about disaggregation, what it is, and then I'm going to go and talk about what's driving the disaggregation market. So disaggregation is diverse, right? One of the things about disaggregation is what we're effectively saying is that the network applications that run on the box come from different suppliers. Maybe some of them are open source. Maybe we buy them from a vendor, just buy their apps to put on. The operating system, we could have a choice. You could have Ubuntu, you could have Infusion, you could have SnapWrap, Cumulus, Picos, Big Switch. There's a whole range of operating systems with different application support. In the same way that you could go and buy Windows and then buy your apps, in the same way you can get Linux and get different apps to run on your Linuxes, and you can have containers and VMs and all this sort of stuff. That's all available to you if you go disaggregate. If you get a white box, or maybe you buy a vendor who's doing it a certain way. The hardware starts to get open. So inside of a disaggregated box, you may be able to start saying, well, I want to choose this ASIC, or I want to choose this QSFP. Maybe I want to use a different set of optics. The optics, of course, the thing about optics is that in a modern switch, a 48-port switch, the cost of 10 gig and 25, 50 gig optics, you're looking at something like more than 50% of the total cost of the switch is actually going to be cost of optics these days. So you really, really need to be looking at the cost of the SFP modules as part of your complete ROI. And when you lock into a vendor and they want to sell you their proprietary optics, you're looking at anything up to 1,000% markups on those products. They're literally, cost pennies, less than $100 a piece in some cases, and they're selling them for over $1,000, maybe as much as $2,000 per unit. For what? It's all just raw profit. The form factor. Increasingly, what we're actually seeing is a change in the way that networking assets are put into form factors. We've seen new racks emerge from the Open Compute Foundation. We've seen the Open 19 racks emerge, not just your old 19 inches back to the Postal Foundation in the turn of the 19th century. There are actually new rack form factors coming online, which, if you're an incumbent vendor with your mainframe that's on a 5 to 10 year replacement cycle, you're not going to don't want to do that, because that's hard work for you. But if you had something that was exploded where you could just clip components inside of it, you could start to think about new ways of racking your switches. And finally, support. And this, of course, is the thing where most customers get, or most people get hooked up in, your shared responsibility, right? That is, you share the responsibility for making this box works as much as all the vendors who put it together. So if you buy your white box from, the hardware vendor, say like Acton or so forth, and you decide you're going to roll your own Ubuntu operating system to run on that, and then you buy SnapRat, or maybe you go and buy Cumulus Linux to run on top of the box, and now you've got to put the two together. The vendors will work with you to make sure that those concerns are addressed, but you're still responsible, or more responsible than you are now. Is that a bad thing? I don't know. I actually think that this whole idea comes up with some new features and it comes with some bad ones. If you may not be equipped to handle disaggregated, this concept of own operating systems or own hardware or mixing and matching, whatever it is. But keep in mind that you've now got the ability to innovate faster. So if I can buy my hardware from company A or company B or company C, the hardware can start to cycle at its pace. What if I'm starting to bring in new operating systems and I want to release a new operating system every 6 months? Well, if it runs on standardized hardware, I can start to increase the pace of the software delivery without waiting for the hardware. There are going to be times when software and hardware are interlinked, sure, but there are also going to be times when it's not, right? So we can start to get faster innovation in networking, and that's one of the things that we've really been starved of for a long time. You're also getting into a reusability concept, right? So keep in mind that if you've got an operating system, you can start to change out the hardware underneath without changing the operating system or the apps. So if you want to use version such and such of this BGP app and you want to run this version of the operating system, you can just change your vendors underneath here. And that starts to give you a reusability. You can reuse the software, reuse your APIs. Or maybe you want to keep that hardware that you've got, but put a new operating system on it to change its purpose. Maybe there's an operating system which is better suited to a campus application, so you retire the switch, put a campus operating system on it and apps, and you move it out to the campus. Not something you can do with your monolithic, right? Once they sell it, those products tend to get packaged. It's this, and it only gets used. So if you have a data center switch, guess what? It goes into the data center, and that's all it's ever going to be used for. Is that the right thing for everybody? Who knows, right? So I do want to be able to talk about this flexibility. You can change the OS, change the application without changing hardware. You can change the hardware with no change to the operating system or applications. Or maybe you could replace the OS. Maybe the vendor's OS that you've been running and their apps aren't very good. And so you actually want to start switching from one vendor to another. You've got choices you never had before. So all of a sudden your support model is different. It's not that you've actually got choices for support that you never had before. That is, I could switch vendors of the operating system or switch vendors of the hardware without changing the other thing and actually reducing the cost of ownership. So let's talk a little bit about what changed. What changed to make disaggregation possible? If disaggregation is happening now in the same way it happened to the server market back in the early 80s, right? And keep in mind that this isn't new. This whole market trend or economics or, this is just standard financial practice. As things change, as markets reach a certain level of maturity, this is what happens, right? But what changed in the networking market to make this possible? So there's four things, I think, four key things. There's many others, but four key things. First of all, the size of the market, the profit margins in the market, the speed of innovation that we're now seeing, and we're also talking about open source. I think open source is absolutely key. So let's drill into those four things a little bit more. The size of the networking market was very small and product was very limited. So this meant you had small batch manufacturing and you weren't able to get scale and you had slow rate of change, right? But what's happened in the recent times is we're seeing this explosion in networking. Data centers are everywhere. We've got the mega scale data centers buying up container loads of switches at a scale we've never seen before. We've seen companies in their data centers literally explode in size, and the networking has expanded to a much bigger market than it ever used to be, right? And this changes the production mechanics and the volumes and the ability to start doing manufacturing runs at a similar sort of scale to what, that we can start to use the same production lines that desktops and servers are made on. There's also changes in manufacturing and a few other bits and pieces, but they're all largely related to the size of the market. Once you have a sufficiently sized market. So the first thing was that the networking market has gotten to the point, there's a critical tipping point where it's big enough to actually use the same manufacturing technology. We could also say that manufacturing technology has improved. It's easier to make smaller batches. That's also true. We've seen changes in chip production. It's much farther. There are now companies who never used to do switching chips, suddenly producing switching chips, but the only thing they do is design silicon. They don't actually do networking. They just do the silicon in the same way that they've done, graphics chips or baseband modems for smartphones. They just design switching chips. It's not a big deal to them to make a chip, but making a chip for a networking company is a big deal. And there are other efficiencies. They drive the market dynamics to some extent. Those are small, but the size of the market is the key one here. The second one, and this is absolutely key, is the profit margins available. The networking market currently runs 65 to 80% gross profit margins on products. That's the cost of the goods sold is actually very cheap, and basically everything at sale price is actually gross margin, more than the majority of it. The net profit on these assets is somewhere around between 30 to 50%. It depends a little bit on which product in the family and how much you sell and how much money you spend on marketing and sales, whether you're fighting to retain market share. There's a whole bunch of mechanics here, but the profit margin is very, very high. Like, for example, desktops and printers, the actual profit margins move between 8 to 9%, right? And in servers, the profit margin's around the 14 to 15% mark. Gross net margin back to the vendor. That's they can give back to shareholders. So if you're talking about 40% margins to 50% margins on networking equipment, and this is what's happening, then that's a market you want to be in. And that's drawing competitors to come into the networking market and expanding that space. It attracts competitors. And the challenge, of course, is that if you're the incumbent vendor and you've gotten, you've grown fat on these huge profit margins and easy sales and you've managed to dominate the market, then all of a sudden you can't start to cheap out. These other people can come in and undercut you very easily because, to them, a 30% margin is very attractive compared to their other assets. So guess what you do? You've got a company up here, high profit margins, high prices. You've got a competitor down here at lower prices. And so this company has to work that much harder to hold the customer on, and this company can just come in and keep working. They don't fight on price. They talk about features and functions and all that sort of stuff in the pitch. But guess what actually happens on the ground? It's always price, right? And price always wins in the end, except for a few. Overall, if you're looking at two different products and they're pretty much the same, guess what wins? All right. So let's talk about speed of innovation. I talked earlier about if you can distract. One of the things that's happening in networking is that the hardware cycle is running at about 5 years. Maybe it's out towards 8 years. So when you've got a chassis switch, or maybe you've got a a rack-mounted switch or a campus switch, you're typically looking at 5 to 8 years to replace those, maybe 10. I often talk about networking being on a decadic cycle. But what's really happening is we're seeing this massive push around software innovation that's largely due to open source, which I'll talk about next, right? So if we could unlock the software from the hardware, I can start to step these two things at different paces. Hardware might run at a 3 to 5 year pace, which is where we're headed now, but your software might start to innovate at a, I don't know, 1 to 3 year pace. But if these two things are locked together, if my operating system is restricted and I can't separate these, then I can't have this one going like this and this one pedaling at a different space. What you actually need is to get them disaggregated. And that's why it's a pressure. We need better software. We need new APIs. We need netconf. We can't wait 3 to 5 years for the IETF or the IEEE to pull a standard out of its butts. We need to get this in now, right? And we saw the 25 gig standard recently just get ratified after 4.5 years, even though everything about it was finished 4 years ago. So it's pretty strange. And, I talked about form factors. We're starting to see this idea of just getting a motherboard, a switch motherboard, and drop it into a known form factor, and boom, away you go. There are problems with that. Depends on your optics, and there's a lot of airflow issues, but that's what they're talking about. Let's talk about open source. I think open source is probably the key here. One of the challenges here is that when vendors write their own stack, when they build, the hardware and then the operating system and then the apps and then the, blah, blah, blah. And then another vendor comes along right next to them. Guess what they build? They build the airflow, the power supplies, the chips and everything. They duplicate it, right? It's all the same thing. They're both actually doing the same work. As a customer, are you getting value because two companies built a power supply or built a chip or built DRAMs or built an operating system and a web server and an SNMP agent? Wouldn't it make more sense for them to use the same one and then add something on the top which is unique? So when each vendor duplicates the same effort, who wins? The customer? Is that innovation? Well, the thing about open source in this, and in the slide I think is shows the way I'm thinking here, is that if you have this open source shared base, like the operating system, there's a lot of shared hardware, well, all of a sudden 80-20 rule starts to kick in. 80% of the functions are already done by open source. There's no added value. I mean, the SSH daemon that's in Linux is perfectly fine. Why are we getting vendors to write their own SSH daemons? Or what about a web server? Why isn't they just using Nginx like everybody else? Why would you go and write your own web server to run on your proprietary operating system when Linux is already done and dusted? And so what we can do is we should be able to see a unique customer value. So it's what goes on top of the operating system that matters if you're using open source. If you've got an open source database on there, you can start to think about your app programming the database instead of actually writing a database. What's the point in writing a database into your operating system? We're going to just go and get one from somewhere else. But the customer value is still the whole thing, right? Just because you're only writing 20% of the code, your total customer value proposition remains that you've got the 20% that was done on top of open source, you get the whole thing, right? Is a networking vendor the right company to write operating systems? We've seen Microsoft as a company devoted to this for years. Do you think that a networking company is actually the right people to write operating systems? And what we know historically is that network operating systems are often insecure. They have incomplete feature coverage. They don't seem to be tested very well. We have very high levels of bugs, and every time you get vendors, and every time you get network engineers together, guess what they talk about? Bug, fail. Found this in the field, brand new product, doesn't work. That's the reality. Clearly, the vendors aren't doing a very good job of this, writing their own operating systems, in my view, right? And the code quality is often very poor. We know that because it takes them 6 months to get a fix. You ring up, you put a case on their technical support, you tell them the bug, and you might wait 3 months, 6 months, 12 months for a fix to come back out in the release cycle. That's not good enough anymore. Okay, and one of the other things about open source is, and this is sometimes a negative for the incumbent vendors, but it also levels the playing field. If 80% of the work is done for you and all you've got to do is put 20% on top, then this starts to make it viable for startups to enter the market. Remember what I said before about, if there's a substantial profit margin in there, starts to attract competitors, the competitor looks at it and says, 80% of the work there is already done by open source. I've only got to do 20% and I can get at that profit. Well, guess what? It's less cost to create a networking solution based on open source. It's less cost to sustain it because I only have to sustain the 20% that I made. and there's less time to market. So I don't need vast amounts of money and huge amounts of capital. I think the biggest example here is a company called Big Switch Networks, which has been a sponsor of the Packet Pushers, and what they've done is they just write the software that goes on top of the switch, right? They sell Dell switches and Actons, and our software is available for Open Network Linux. They've contributed to open source, so anybody can use it. But for them, you can use that on those switches, and guess what? They don't need to be $1 billion company to be profitable. They only have to support the software. They don't need to buy $1 billion worth of switches and stick them in warehouses and hire companies to do arms and leg support and build a 24/7 TAC around the world and a call-out system that tracks if everybody, blah, 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 and make sure the goods are received. All that cost is just shared with Dell, right? So that's a way that comes to the market. So let's talk about the competitive landscape in an open source disaggregated world. Incumbents have deep customer relationships based on 10, 20 years of selling network mainframes, like these monoliths, right? And they've also got huge internal costs associated with that. They've got legacy products with the customized operating systems using legacy tool chains from 20 years ago, like software tools from 20 years ago. They've got these long product cycles. Sometimes they've committed to companies that they're going to keep a product around for 20 years and support it, software and hardware, right? And they've got to carry that cost on the books for years. On the other hand, new entrants, startups, or companies coming laterally, so big incumbents in the server market or otherwhere in the IT, moving into the network space, they must find those customers and dislodge the incumbents, right? Which is not easy. Long sales cycles creates cash flow problems. So if you've got to put an enterprise sales force down on the ground, but increasingly the internet's changing that relationship, right? And there's a real perceived risk. A lot of customers go, oh, I love my mainframe, couldn't possibly leave it. It's these little PCs aren't going to fly. This concept of Microsoft software on an IBM PC is just not the way it's going to be. This disaggregation isn't going to. We know how that turned out, right? So that's bunk, I think, ultimately. But it's up to people like you and I to recognize this change and go with it. There is a key change. There's a real key change here, and there's a thing that's driving the market, and that's these mega scale data centers. So the Netflix, the Amazons, the Googles, the Facebooks, the Chinese mega scale data centers as well. They've all got the problems, right? If you think about it, those mega scale data centers are now actually buying stuff, right? They're the ones deploying 25, 50 gig, 100 gig and buying it en masse. And this is driving manufacturing volumes at the high end. So where before it would be like, let's have a couple of 100 gig ports and maybe some special people will bring down the 100 gigs and, over 5 years volumes will gradually ramp. What's happening is Amazon's going 100 gig? Yeah, we'll have lots of that. Container loads of it. We'll get it all done. Buy in a box. All of a sudden the manufacturing goes from boom, boom. And those products are coming to market way faster than anybody thought that they would be. And this is changing the mechanics, right? And then they're taking that technology, putting it into their data centers and then proving it at scale. Does 100 gig work? Could be scary. Gosh, back in the mid-90s, that 100 meg, I don't know. It's going to be a few years before they work that out. Amazon takes it, Google takes it, Facebook puts it in their data center, and they prove it out on day one. Guess what? We get the benefits of that as enterprise IT. And then those same companies are then releasing that technology, they're open sourcing that technology to drive the market in new directions. That's a key change. There's a bunch of other issues around that, but I'm going to pick those three and go with it. So, disaggregation, good or bad? It's certainly a change. I think for many people, where my biggest fear is that enterprise IT has kind of de-skilled itself over the years, right? There's a lot of us who don't know what an ASIC is or don't understand the concept of an operating system, and we're so caught up with these legacy CLIs and configuring this and finger banging the keyboard that and all this sort of thing that we've forgotten the bigger picture, that x86 with the Linux operating system with the apps on the top, maybe, or x86 allowed virtualization to come in and then to run virtual machines with operating systems. This disaggregation process allowed servers to move at this pace and Windows to move at this pace and VMware to cycle at this pace and apps to move at this pace and all the apps. And we didn't have to bring them all together and weld them all and wait for our vendors to give us what we asked for. So in that sense, disaggregation you should certainly be embracing, but there are, you will need to skill up, and I think there's the fact that you will probably save a lot of money is key. Buying these pieces as elements, there's a whole bunch of flexibility, there's a bunch of innovation that you can do. On the other hand, the networking market isn't that large. It's entirely possible that the process of disaggregation, this idea of hardware and software and apps might fail because the networking market is a bit smaller. I mean, that's why it hasn't happened up till now, is that it wasn't worth forcing the transition through and breaking them away. Like, out of an entire enterprise IT budget cycle, your networking budget is usually only 3, 4, 5% of the overall cost of your budget. So even if you could improve the cost effectiveness of your network by 30%, you're still only making like a 1% difference in the overall IT infrastructure that you've got. And I understand that with CIOs, it's fair to respect the fact that actually the networking isn't as big as a problem as your Oracle database. If you could solve those licensing issues, you could probably move the needle by 5 or 10% if you could reduce your Oracle licenses, right? That's a fact of life. I respect that. IT infrastructure, the cost of storage arrays is a bigger problem than networking costs. So maybe it's worthwhile just saying, I've got other problems in other places. I'm happy to pay for mainframes for this situation, and somewhere down the track it'll come in. But I hope what I've managed to do is explain to you why the market for disaggregation is coming along, why the market is driving it, and why you may well want it in your own case. I think it's key, and I do also believe that you should probably be doing it sooner rather than later, because the ability to innovate, to cycle your technology and bring on new features while reducing the risk. It's a different type of risk, but it's the same risks. And if you can get away from the mainframe, the monolith, the single, the one, locked into a supplier, and start getting some flexibility, your networks might be better off. If you've liked this video and you think this was pretty cool or something like that, or even bad, or you want to argue, please, in the comments below, or hit us up on the website at packetpushers.net. You might like to hear more about podcasts and stuff. Either way, look forward to seeing you.